In October 2017, something quietly crossed into our solar system. There was no explosion, no warning sirens, no breaking news headline at first. Yet astronomers would later realize that this object had traveled between the stars, drifting through the vast emptiness of interstellar space for millions, perhaps billions of years before passing near our sun. And when NASA and European observatories finally understood what they were looking at, one unsettling fact became clear. This was not from our solar system. For centuries, humanity believed the space between stars was mostly empty, a cold, silent void broken only by distant light. But modern science has begun to reveal something far stranger. Objects can and do move between stars, and sometimes we detect them. The first detection that changed everything. The discovery began at the Pan-STARRS 1 telescope in Hawaii, a system designed to scan the sky for near-Earth objects. On October 19, 2017, astronomers noticed something unusual. The object was faint, fast, and moving on a trajectory that made no sense. At first, scientists assumed it was a comet or asteroid from our own solar system. But as calculations improved, a disturbing detail emerged. Its speed was too high to be bound by the sun's gravity. Its path was hyperbolic, not elliptical. It was entering the solar system, not orbiting within it. This meant only one thing.
The object came from interstellar space. NASA soon confirmed the conclusion. European space agencies reached the same result independently. For the first time in recorded history, humanity had detected a known object moving between stars and passing through our neighborhood. They named it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first.
Why scientists took this so seriously? Oumuamua was not just another space rock. It behaved in ways that challenged existing models. It showed no visible comet tail. It reflected light in strange patterns. It appeared long and possibly cigar-shaped. And most puzzling of all, it accelerated slightly as it left the solar system without any obvious propulsion. NASA scientists were careful. No sensational claims. No dramatic conclusions. Instead, they did what science does best. They asked careful questions. Natural explanations and their limits. Several explanations were proposed. One idea suggested Oumuamua was an unusual type of comet, releasing hydrogen gas that couldn't be easily detected. Another suggested it was a fragment of a destroyed exoplanet, hardened by cosmic radiation over time. Each explanation explained some aspects, but not all. And that's what made this detection so important. Not because it proved anything extraordinary, but because it revealed how little we truly know about interstellar space. A second visitor confirms the pattern. In 2019, something remarkable happened. Another object was detected entering our solar system from interstellar space. This one was named 2I/Borisov, and unlike Oumuamua, it behaved exactly like a comet. It had a clear tail, a familiar chemical signature, a predictable structure. For scientists, this was a relief. It proved that interstellar objects are real, detectable, and natural. And it suggested something even more profound. The space between stars is not empty, it is filled with travelers. What NASA and European scientists now know. Based on current data, astronomers estimate that thousands of interstellar objects pass through our solar system every year. Most are too small or too fast to detect. But with new telescopes coming online, such as the Vera C. Rubin Observatory, scientists expect to detect many more. This means we're entering a new era of astronomy, an era where we are no longer studying only our own cosmic backyard, but the debris, messengers, and remnants of distant star systems.
At this point, one question naturally arises. If natural objects can travel between stars, what else could be out there, moving silently through the dark?
The European perspective, why this matters beyond America. While NASA confirmed the interstellar origin of these objects, European observatories played a crucial role in understanding what they truly represented. Facilities across France, Germany, Spain, and the United Kingdom began independent analyses. What interested European scientists most wasn't the mystery itself, but the implication. For decades, astronomy assumed that star systems were mostly isolated. Planets formed, asteroids stayed put, and debris rarely escaped their parent star. But these detections shattered that assumption. If objects could escape one star system and wander into another, then stellar systems were not isolated at all. They were connected, not by light alone, but by matter. A galactic exchange we never knew existed. European astrophysicists began calling this phenomenon a form of galactic exchange. When planets form, massive collisions occur. Asteroids smash into protoplanets, moons are ejected, fragments are thrown outward with enormous velocity. Most fall back. Some don't, and a tiny fraction achieve escape velocity, enough to leave their home star forever. Those fragments drift for unimaginable spans of time. Millions of years, hundreds of millions, sometimes longer, until one day, by chance, they pass another star, like ours. Why scientists call these objects time capsules. Unlike asteroids formed in our solar system, interstellar objects are untouched by our sun. They carry chemical signatures from other star systems, clues about planet formation elsewhere, evidence of how common or rare Earth-like systems may be. European researchers describe them as cosmic fossils, not alive, not artificial, but ancient. Each one potentially older than Earth itself. The acceleration mystery, without sensation. One of the most misunderstood aspects of the first detected object was its slight acceleration as it exited the solar system. Some media outlets rushed to speculate. Scientists did not. Instead, European teams collaborated with American researchers to test every natural explanation first. Outgassing from invisible gases, solar radiation pressure, unusual surface composition. No single explanation solved everything, but none required extraordinary claims either. And that restraint mattered, because science advances not by guessing, but by eliminating what doesn't fit. A quiet revolution in astronomy. There was no dramatic press conference, no countdown. But behind the scenes, astronomy changed. Funding priorities shifted, detection algorithms were rewritten, telescope time was reallocated, because scientists now knew something critical. Interstellar space is not empty. It is active, dynamic, and occasionally it visits us. What comes next, according to European space research? Upcoming observatories in Europe and abroad are designed to detect faint, fast-moving objects earlier than ever before. The goal is simple: detect interstellar visitors sooner, study them longer, learn where they came from. Future missions may even attempt close flybys, not to intercept, but to observe, to read their surfaces, measure their composition, and reconstruct the story of another star system without ever leaving ours. The bigger question Europe is asking: European scientists are not asking whether these objects are artificial. They are asking something far more important. How common are planetary systems like ours? Because if debris from other stars reaches us regularly, then planet formation must be widespread. And if planet formation is widespread, then Earth may not be unique, not in mystery, not in history, not in significance. A new way of looking at the night sky. For centuries, Europeans looked up and charted stars for navigation, calendars, and myth. Now, they look up knowing something different, that pieces of distant worlds may be passing silently overhead, unnoticed, unannounced, carrying stories older than civilization. At this point in the story, one realization becomes unavoidable. Humanity is no longer just observing the universe. The universe is occasionally observing us back by passing through our space. How this discovery changes humanity's future. The discovery of objects moving between stars did more than reshape astronomy. It quietly changed how humanity sees its place in the universe. For the first time, we understood that our solar system is not a closed environment. It is not sealed. It is not isolated. It is part of a larger, dynamic cosmic network. Interstellar space is not a barrier. It is a highway. Why this matters for the future of space exploration. European space agencies began re-evaluating long-term exploration goals. If natural objects can travel between stars, then studying them offers something unprecedented, a chance to examine material from another star system without building an interstellar spacecraft. This is why scientists call these objects natural probes. They are messengers that arrive without fuel, without guidance, and without intent. Yet they carry answers. What interstellar objects can teach us? From these visitors, scientists can learn how common rocky planets may be across the galaxy, whether organic molecules form easily elsewhere, how violent planetary formation truly is, whether solar systems evolve similarly or chaotically. European laboratories began preparing for something new, the possibility that one day an interstellar object could be studied up close, perhaps even sampled. Not tomorrow, not next year, but someday. The psychological impact we rarely talk about. There is another consequence, one rarely discussed. Knowing that material from distant stars passes near Earth changes something subtle in the human mind. It collapses distance. The stars no longer feel impossibly far. They feel connected. For European audiences, shaped by centuries of philosophy, exploration, and scientific skepticism, this realization resonates deeply. The universe becomes less abstract, more intimate. Why this story isn't about aliens. It is important to be clear. This story is not about extraterrestrial intelligence. It is about something far more grounded and far more powerful. Cosmic continuity. The idea that the same processes shaping our world are happening everywhere. That stars are not isolated islands. That planets are not rare accidents. That matter travels, mixes, and remembers.
What scientists are watching for now. Today, astronomers actively monitor the sky for fast-moving, unusual trajectories. They are not waiting for something dramatic. They are waiting for data. Because each new detection refines models, improves predictions, and reduces uncertainty. Mystery does not weaken science, it strengthens it.
A quiet truth hidden in plain sight. There is a quiet truth behind this entire story. Humanity did not discover something extraordinary because we were looking for wonder. We discovered it because we were looking carefully. No assumptions, no expectations, just observation. And the universe responded.
Looking forward, not up. Perhaps the most profound shift is this. We no longer look at the sky only to see where we are going. We look at it to understand where we came from. Because some fragments passing overhead may have formed around stars long gone, stars that lived, burned, and disappeared, yet parts of them still wander.
The final realization. When NASA and European scientists confirmed that something had moved between stars and passed near our sun, it wasn't fear they felt. It was humility. A recognition that we are part of something vast, interconnected, and still unfolding. The universe is not distant, it is active, and sometimes it comes to visit.
We used to believe the space between stars was empty, silent, meaningless. Now we know better. Something crossed that darkness and reminded us that the universe is far more connected than we ever imagined.
Something crossed the stars and reminded us how connected the universe truly is. This is Mind Burst Universe. Subscribe and join us in the next story.